Thank you again, Catherine, and welcome all. So today I'm not going to talk through the specifics of what the IStructE particularly wants of the academic process, but more the reasons why the academic process of learning for our students is important. As you know, the built environment declares climate change and biodiversity emergency is an active initiative to engage with the construction profession and to obtain their buy-in to taking action in addressing the crisis which faces us. There are 222 structural engineering companies and academic bodies that have signed up on the Structural Declare link, 125 civil engineering companies and academic bodies, a further 56 contractors, as well as 1,136 architects, 146 landscape architects, 104 building services, but most importantly, over 2,500 students from across the built environment, most of whom will be attending the educational establishments represented here today. So how does this commitment translate into engineering practice? And why is it so important now more than ever that graduates from engineering degrees are fully versed in the impact of their sector on climate change and sustainable design, to be able to calculate the environmental impact they will have on the world in their application of engineering theory into creating and adapting the built form, seeking to minimize the carbon outputs. As Catherine said, I'm a director of an SME civil and structural engineering company called Renaissance, based in the Northwest, with a team of 29 people. And for me personally and our business, the philosophy is simple: sustainable living, sustainable design, with a straightforward mantra that we all know of reduce, reuse, and recycle. About 20 to 30 years ago, when you looked at whole life carbon profile of, say, a building, the simple split would have been 1/3 to 2/3 embodied versus operational. However, with the decarbonisation of the national grid, improved building envelope performance, and improved energy efficiency of equipment, this has resulted in a significant shift whereby the operational aspect is now much lower in proportion, and for well-designed buildings moving in even closer to zero. Meanwhile, the embodied energy has remained static and is a key challenge now facing us. These are some specific stats from the Sturgis Carbon Profiling, a group led by Simon Sturgis, whom some of you I'm sure will know. And as you can see, the current profile of a diverse mix of buildings shows the levels of operational whole life carbon varies from just over 20% to 30%, with embodied carbon sitting at between 70 to 80%. This doesn't mean that we need to start constructing buildings using straw bales, though we have designed a number of those, or even cardboard, and I've designed with one of my co-speakers today, Rod, a number of those. And we have to be pragmatic when looking at the viability of all future buildings being constructed in timber, as we have an issue regard to land take to grow sufficient material and a sufficient quality rate, to meet demand. Every spare centimetre would be taken up, limiting space available for food crops and space left for us to live. But what does become interesting is a concept of new materials and placing the likes of, say, graphene, which developed here in Manchester, into the mix, and its potential to contribute to the built form. So with embodied energy being our collective big target, considering the first point of our mantra, reduce, and rather than talking today in terms of tons of carbon, I'd like to define it in terms of pounds sterling. In the world of development and construction, whilst carbon is becoming a more common unit of currency, informing ourselves and our clients of the right decisions in working towards a low to zero carbon development, commercial viability still remains a key driver. So to highlight our industry dilemma, I will talk in pounds sterling to highlight the issues and next steps which need to address the shortfalls in our profession and address the climate crisis today and in the future. Within the £100 billion per annum construction industry in the UK, 25+% of this 100 billion, that's 25 billion pounds, currently can be defined as waste. 20 billion of this is a result of common construction errors. That's people getting it wrong for a variety of reasons on site and having to start again. These statistics are from the 2016 Get It Right initiative, and this has been contributed by various strands of the professional sector. And one solution to addressing this is the use of MMCs, modern methods of construction, where factory manufacture of building components can control, manage and reduce waste, and the potential for on-site errors causing this heightened carbon production. The other 5% can be saved through lean engineering. And by this, I mean removing over-design. And this is particularly driven by brief and over-specification requirements for use compared to what the building will ever support in its life, and partly driven by a syndrome of having some in hand in case the client changes their mind at some point down the line. As a business, we seek to address this by ensuring that our designs are fully optimized with an efficient structural grid and any fat removed, using material where it's really needed. And we're fortunate enough to work with enlightened clients and co-collaborators who see the value of those early stage discussions to define the building brief along with the structural form and ensure that the tail isn't wagging the dog in providing a commercially viable scheme. Put simply, these savings equate to savings in carbon emission. The second and third points are somewhat intertwined: reuse and recycle, which in engineering design terms involves the refurbishment of existing building stock. And repurposing existing buildings can be somewhat more of an intellectual challenge than a new build. Considered reuse, particularly of listed assets, continues to be a successful part of our business. We've found that these buildings which have been repurposed have enhanced a sense of place of their location and acted as a catalyst for further regeneration and development. It's important that the design process works with the building, allowing it to tell you what's possible, clearly allowing future second and third repurposing to take place. Ensuring that the built environment which we design today is of a quality in terms of materiality and fabric, and that these buildings can be repurposed when they reach the end of their current use and continue to give back to their place is essential. The carbon stats are pretty clear. We have the opportunity to take action and reverse the process. It's not too late. The education of our next generation of engineers is critical in ensuring that the climate crisis can be met, and their understanding of carbon counting and whole life carbon must be an integral part of their learning. This application is an integral part of our business delivery, with our buildings now being awarded a carbon level of performance similar to the grading of domestic white goods. We have to act now and start to bring down our carbon production levels by 15 to 20% year on year to achieve zero carbon targets set by local and central government. If we do nothing, then our carbon budget will run out in less than 5 years, and that's no time at all. The situation really is pretty black and white. We have to act. It's our only choice. and therefore it is critical that our graduates are fully versed in the essential need to minimise carbon, to be furnished with the knowledge, the language and the skills to confidently contribute to our industry. Thank you.